Hi, welcome to my tutorial on solving equations. This is the first of two parts. The second part will look at more complicated equations where you've got unknowns on both sides. But for part one, we've got 6 examples here to look at. I'm going to use the balancing method to solve these equations because it's a lot more versatile, can be used for the more difficult questions later on. So with the balancing method, we assume that we've got the middle of the equation where the equals is. I'll refer to this as the left-hand side and the right-hand side. What I'm trying to do is I'm trying to end up with x on the left-hand side equals a number on the right-hand side. In order to do that, I need x on its own, so I need to get rid of this 7 here. In order to get rid of a positive 7, I just need to take it away. But with equations, whatever I do to one side, I must do exactly the same to the other side. So if I take 7 away from the left, I must take 7 away from the right. Once I've done that, I'm left with nothing here. So I've just got x. And x now is going to equal 10 take away 7, which is 3. That's the most simple equation you can get. The second one, e.g. 2, we've got a negative number here. In order to get a negative to 0, I have to add 3 to it. So this time I'm going to be adding 3, but whatever I do to one side, I must do to the other side. So I add 3 to the 12. If I write that out now, I'm left with x. Negative 3 add 3 takes me to 0. So x is going to equal 12 add 3 gives me 15. For the third one here, I've got 2x equals 10. Now in algebra, if I've got 2x, that really means 2 multiplied by x, or 2 times x. 2 times x equals 10. With the first one here, to get rid of the 7, I took 7 away. I did the opposite to addition, which was subtraction. To get rid of the negative 3, I added 3 to it. I did the opposite to negative, which is addition. Here I've just told you that the 2x means 2 multiplied by x. So to get rid of the 2, I'm going to do the opposite. I'm going to divide by 2. But I'm going to use this line here, this fractional line, to show division, because this is how we show it in algebra a lot more than the traditional method like that. So get used to seeing it like that. Now 2x divided by 2 gives me 1x, because 2 divided by 2 gives me 1. Whatever I do to the left-hand side, I must do the same to the right-hand side. 2x divided by 2 gives me 1x. We don't need to write the 1, so we just have x equals 10 divided by 2 is 5. And the last one here, x divided by 2 equals 5. The opposite to divide is going to be times. So this time, to get rid of this division, I'm going to do the opposite, which is to times it by 2. But whatever I do to one side, I must do to the other side. So x divided by 2 times 2 just leaves me with 1x, which is x, and 5 times 2 gives me 10. Those are the 4 basic things we need to do to solve equations. Now for EG5 and EG6, we're going to put more than one of these together in order to solve these two equations. If we have a look at EG5 here, we've got 2x plus 6 equals 12. We're going to get rid of the number 6 first of all, using method 1. So here, to get rid of the 6, I take away 6. But whatever I do to the left-hand side, I must also do to the right-hand side. So I'm now left with 2x, the 6 has gone, equals 6. Now I'm going to use my third method here. In fact, it's the same thing, 2x. So to get rid of the 2, I need to divide by 2. Whatever I do to one side, I must do to the other side. So I divide the 6 by 2. 2x divided by 2 gives me 1x. And 6 divided by 2 gives me 3. EG5. Okay, EG6. Now for this one, we've got this fraction part in it here. We've got the 4x plus 2 and we're dividing it by 3. Now to get rid of the 3, remember from example 4 here, I have to multiply by 3. That will get rid of the 3 on the bottom there. But whatever I do to one side, I must also do to the other side. So I must multiply the 5 by 3. Now if I write this out again, I've got 4x plus 2 equals 5 times 3, which is 15. Now I'm in the same situation as what I was there. So the next thing I need to do is get rid of the 2 by taking 2 away. But because I've taken 2 away from the left hand side, I must also take 2 away from the right hand side. Write it out again once I've done this. 4x, the 2's now disappeared, equals 15 take away 2 is 13. And then finally, to get rid of the 4, because it's 4 times x, the opposite to multiply, opposite to times, is divide. So I need to divide by 4, but I need to divide by 4 on the other side as well. 4x divided by 4 leaves me with x, and 13 divided by 4. I can say how many 4's go into 13? Well, there's 3. But there's 1 left over, so I write the 1 on the top and write whatever the denominator was initially on the bottom. My answer becomes 3 1/4.